All right, so let's jump to our problem. So the problem says you are given two integers num1 and num2 sorted in non-decreasing order, and two integers m and n representing the number of elements in nums1 and nums2 respectively. So you just have two arrays, and m and n are representing the length of those arrays. The task is to merge num1 and num2 into a single array sorted in non-decreasing order. The final sorted array should not be returned by the function. So what this means, like if we can take a look at our boilerplate code here, it's returning void. So we are not returning the merged array. And how are we going to do that? But instead be stored inside the array nums1. Okay, so we need to store our solution back into nums1. To accommodate this, nums1 has a length of n plus m, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored, and nums2 has a length of n. Okay, so you're given an example. So for example here, the challenge is to match this. You're given an example where we have these elements. Okay, so 1 2 3. So here you can see we have 1 2 3 4 5 6. That's the size of the entire array, but this m number, it's saying 3, which means that's the size of the actual numbers that are sorted that are not zeros. So these zeros are placeholders. I'm guessing this is where we need to put the remaining of the numbers after we merge. Then nums2 is 256, which are going to be put inside here in a sorted list, and then the size of this is 3. So the output here is going to be 1 2 2. So we are not going to skip any repetition. So in this case 1 2, we need also to consider 2, and this is the sorted list, and you can see the 3 zeros are now replaced by the new element that we've sorted. So the explanation is saying the arrays we are merging are 1 2 3 and 2 5 6. The result is this, with the underlying elements coming from nums1. So the idea is the answer that we need to put it back inside this. That's why we don't have a return type. So same applies with example number 2. We have one element and the other one is empty, and the output is 1. Okay, so this is the sorted element, this one is empty, so there's nothing there. Yeah, so I think we actually get the gist. So here the output is 1 because nums1 is 0, so we're going to replace it with this, and we've been given a little bit of constraints here, where 1 is between 1 and 200, the length of the both arrays, and also this. Taking a look at this, right, you need to be able to build an intuition in terms of how best you are going to solve this, and it's always good to know how to brute force this. So for example, for my first attempt, I'm going to demonstrate how we can brute force this. So it's simply going to be joining the two arrays, okay, nums1 and nums2, and then once I join them, I will then sort them, and the runtime of this will not be linear. It's going to be n log n, which is a little bit which is not better than O of n, because the sorting algorithm will take time. So let's just quickly implement this. So the way I will implement is I'm going to create a pointer, which I'm going to initialize to 0. So this pointer, I'm going to use it to store results back to nums1. Okay, so the way I would do it is I'm going to iterate. So in this case, I'm going to use int. So I'm going to say int, I'm going to initialize it to m. The reason why I'm initializing it to m is, remember, m is our size of nums1, which has elements. So in this case, m is 3. So I want to start my pointer. I want to start iterating. I want to start my pointer pointing at this mth element, size 3. So in this case, it's going to be 0 1 2 3. So I wanted to start here at the first 0 here. That's why I'm initializing to m. And then I'll say I, in this case, is now less than nums1. So remember, we're iterating over nums1 dot length I plus plus. So once I do this, I will simply say nums1. So I now want to replace those zeros in nums1. So at index I, I'm going to replace them with whatever I have from. So my pointer now, this pointer that I've declared here now, is pointing now to the nums2 now, but starting from index 0. So I'm going to replace those 3 elements. For example, here my pointer is pointing at 2. I'm going to replace I'm just going to copy these and put them in nums1. That's simply what I'm doing here. So here I will say nums2 pointer, and then after I do this operation, I need to iterate my pointer. Okay, pointer plus plus. So what this does is it's simply copying these three elements where these zeros are starting, which is after the length of the array. That's simply what I've done. So in this case, I've copied whatever is nums2 to nums1. Okay, and this list is not sorted at all. And to sort this guy, I just need to say to use the function like arrays.sort. Okay, then I'll sort nums1, and that should be it. So let's try to run this. Okay, it looks like I have an issue here. So for int I equals to m, oh, I put a comma here instead of a semicolon. Okay, let's see. Okay, so it looks like our three test cases have passed. Okay, let's try to submit this. All right, so it looks like it has passed all the 59 test cases, and our solution is actually beating 27% of these submissions. And so the runtime of our solution here would be this, it will be big O of n log n, okay, because of the sorting. So this is because of this sorting method in our Java. So most of these sortings n of log n, okay. And the space complexity here, we didn't introduce any space, so it's constant. Okay, so now how do we make this better? We want this to be linear, which means we want the the time complexity to be O of n. Okay, so to improve this a bit, I'm going to delete this now. So this is the brute force. I'm going to improve it a little bit. So the way I'm going to improve it is like exactly what I showed you before in the previous tutorial where I showed you how to use the two-pointer technique. So now let's use the two-pointer technique. I'm going to initialize two pointers, p1 to 0, okay, and also p2 I'm also going to initialize it. So these two pointers are going to point to the first one. P1 is going to point to num1 and p2 is going to point to num2. So just like what you explained in the algorithm, I'm going to have a while loop here in our pseudocode. So this while loop, so I will say while p1 is less than, I need the length of the array of nums1. So the length here we've been given as m. So I'll say m here. So I'll say while p1 is less than m, and so here we can't use nums.length, because if we use nums.length, it will give us including the 0 positions. So we don't want we don't want those. We just want the elements that are not zeros, which are not placeholder. So that's why I'm using m here. So I'll also do the same while p2 is less than also n. So remember we said in the first while loop we want to do some operations we're actually going to decide whether we're going to move pointer 1 or pointer 2 to the left or both. Okay, so in this case what you want to do here is so if I can actually quickly go ahead and go back to the dashboard, the whiteboard, like what we showed previously. So here what we want to do here, so this is a sorting problem. So here we have 1 2 3 6. Okay, so if these two arrays are sorted, okay, what it means is our pointer 1 is pointing here, okay, at the 0th index. So we're going to compare p1 and 6. Okay, so we're going to say, is 1 less than 6? If 1 is less than 6, it means 1 is going to retain its position here, and we're going to move p1 to the next pointer. So p1 will then move and point at 2, but p2 is still going to remain here. Okay, so which means in our result solution we're going to maintain it, it's going to be here, or we'll move it to some temporary array or something. Okay, then we also do the same thing because these are sorted. So we do is 2 less than 6. In this case, yes, 2 is less than 6, so 2 is going to maintain its position. We'll move it to a temporary storage or whatever, and then we'll move p1 again to this. So we continue doing this. Is 3 less than 6 is true, yes, we'll continue. 6 less than 6 is the same, so it doesn't matter, we can keep it. And then here you can see we are now left with this. So these are the 3 in this example that are left, would then be handled by the 2 while loops that we explained earlier on. Those 2 while loops, we'll simply copy the rest to this and move the pointer 2 or pointer 1. So in this case, it's going to be pointer. So with this, instead of 2 here, maybe we had 1. Okay, so let's say we had 1 here. So when we moved it to 2, we're going to say if 2 is 2 greater than 1. Okay, so if 2 is greater than 1, it means 1 will maintain its position. So p1 will still be at 2, and then we'll move it here. So it's just a decision, just to decide which one we're going to move. So let's simply go ahead and translate this to code. So like what I've said, if you haven't watched the first part of the video where we explain this, you need to check it out. So now let's continue the algorithm. So what we need to check now to decide which point we're going to move, we're simply going to say if nums1. Okay, so nums1, this is where our pointer 1 is pointing. So if it's less than whatever the number that nums2, pointer 2 is pointing, okay, if it's less, we are simply going to add this. So here I'm simply going to introduce a temporary array here. So I'm going to say like something like list integer, then I'll call it result. So this result is going to be an array list. Okay, so this array list is the one that is going to be responsible for storing our result, and then I'll do another copy to copy it back to nums1. Okay, it's not going to compromise that a lot, but it's just going to introduce an extra space here. And then yeah, so let's see how it goes. So in this case, if p1 is less than this, which means inside our result now, we now need to add nums1. We now need to add the lesser number where pointer p1 is pointing to. Then after we add it, then we move pointer 1 to the next index. Okay, so this is the first step. Otherwise, we need to do the reverse of this. So we are going to add, so if it was greater, if p1 was greater, we are going to add the lesser number, which is pointer 2, wherever it's pointing. And then we move pointer 2 plus plus. Okay, so this is our first while loop. Okay, where we just deciding whether to move pointer 1 or pointer 2 or both. So in this case, we don't have the both situation because of the kind of our problem. So now let's now exhaust. So here let's exhaust the rest of the elements in maybe nums1. So we start with nums1. So remember we had another while loop which was saying if p1 again is less than m. Okay, we now need to simply add whatever those results are. So we are adding whatever is nums1. Okay, whatever p pointer is pointing to, these are now the excess. And then we move pointer 1 plus plus, and then we also do the same for nums2. Okay, these are the remainders in nums2, because after the first iterations there's a possibility like if our arrays doesn't have the same length, we might need to just exhaust and copy everything in the remaining which is remaining. So here we also do the same. So p2 is less than n. So if p2 is less than n, we need to add copy everything in nums1 in this case, so nums2. and then P2 where P2 is pointing, and we'll continue copying until we exhaust that list. So P2 plus plus. Okay, so we move our pointer to. So this will take care of if our two arrays are not of the equal length. Okay, so now what we have done here is we have actually sorted this array, you see, without using a sorting method, and this is actually running in linear time. But here there's only one catch. Here we introduced a new memory, which is result. But remember, the question is asking us to put the result back in nums1. So to do this, I'll simply run a for loop here where I'm going to copy the results back. I would say copy the result into nums1. Okay, so here I'll copy the result into nums1. So I'm simply going to iterate int I equals to 0. I is less than maybe the result dot length. It's an array list, so its size. Then I plus plus. So here we're simply copying everything. So we'll say nums 8. So it's going to start at index 0. Whatever the number is there at the moment, we're going to override it with the result dot get index 0, whatever index I. So this will do the override. And we are done. We don't need to return anything. So let's try this out. Okay, so it looks like I do have a bug here. So here this is nums2, not num. Okay, it's a typo. Okay, perfect. So it ran. So let's try to submit it. Perfect. Yeah, so it actually looks like our solution is perfect. It's linear. So the reason why this solution is linear, like what I've said, this for loop here for copying things, this one is linear runtime. This is linear. Doing this operation is also linear. Okay, so all these operations are linear. Same applies with this one. Then same applies with this while loop. It's also linear. The only caveat here is we only have an extra space here. So our space complexity is O of n because we are not initializing it to anything. So we have introduced the space. Okay, that's the only caveat. But our algorithm runtime is perfect. So if you want to sacrifice space, you can actually do it this way. So yeah, so this was the two-pointer solution, but there is another third solution where you can achieve the same but without necessarily introducing an extra space. So maybe I would cover that in the next video. If you have enjoyed this video, please make sure you like and subscribe to the channel. It will also help me out, and get the algorithm reaching out to more people. I hope you find this video useful. I will see you in the next one where we will implement a solution without necessarily introducing extra space. See you in the next one.